Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about Peltier effect. Peltier effect discovered by the French physicist Jean-Charles Athanas Peltier in the year 1834. It describes the creation of a temperature difference at the junction of two different materials, typically semiconductors, when an electric current is passed through them. This effect is a direct consequence of the fact that electrons carry not only charge but also heat. When electrons move from a material with low Fermi level to a material with high Fermi level, they must absorb energy in the form of heat to make the transition. Conversely, when electrons move from a high Fermi level to a low Fermi level, they release energy in the form of heat. Let us look after the principle of operation. The Peltier effect is a thermoelectric effect, meaning it involves the direct conversion of temperature differences to electrical voltage and vice versa. Unlike Joule heating, which always produces the regardless of the current direction, the Peltier effect can either heat or cool a junction depending on the direction of the current. Consider a Peltier device consisting of two dissimilar semiconductors. One is N-type and the other one is P-type, which is connected electrically in series and thermally in parallel. When a DC current flows through the circuit, uh, two things happen. One is cooling at the cold junction or heating at the hot junction. At one junction, the cold junction, electrons flowing from the p-type semiconductor to the n-type semiconductor must absorb heat to overcome the energy barrier. This absorption of heat causes the temperature at the junction to decrease, resulting in a cooling effect. Next, at the other junction, say the hot junction, electrons flowing from the n-type semiconductor to the p-type semiconductor release heat as they transition to a lower energy state. This release of heat causes the temperature at the junction to increase, resulting in a heating effect. So the amount of heat absorbed or released at the junction is proportional to the current flowing through the circuit and is described by the Peltier coefficient, which is a material property that depends on the temperature. Now, let us look after the Peltier heat equation. So it is given by Q is equal to pi into I, where Q is the heat absorbed or released with the unit watts, and pi is the Peltier coefficient, and unit of pi is volts, and I is the electric current in amperes. So let us look after the advantages of Peltier devices. So they are used in several advantages over traditional cooling and heating methods. So Peltier modules are small and lightweight, making them suitable for portable applications. So we can say that it has compact size and it is lightweight. They also allow for precise temperature control, making them ideal for applications requiring stable temperatures. Next one is Peltier devices have no moving parts, resulting in quiet operation and reduced maintenance. They do not use refrigerants, making them environmentally friendly. They can be used for both heating and cooling by simply reversing the direction of the current. So it has a reversible operation. Next, let us see some of the limitations of Peltier devices. So despite the advantages, Peltier devices also have some limitations. So they typically have a lower efficiency compared to the traditional cooling and heating methods, especially at large temperature differences. Also, the cooling capacity of the Peltier modules is limited by the materials used and the size of the module. Peltier devices generate heat at a hot junction, which must be effectively dissipated to maintain efficient operation. Peltier modules can be more expensive than the traditional cooling and heating components, especially for high performance applications. There are diverse applications of Peltier effect, which is used in wide range. The main applications are say thermoelectric cooling, where it is used in applications such as say portable coolers for say food and beverages, electronic component cooling, where the cooling of the sensitive electronic components like microprocessors and laser diodes are needed, and in laboratory equipments, temperature control such as say thermal cyclers and incubators. In medical devices, cooling and heating can be used such as in blood analyzers and temperature controlled blankets. Next, it is used in thermoelectric generators. So almost primarily it's used for cooling. The Peltier effect can also be used for generation of thermoelectric power. By applying a temperature difference across the Peltier module, a voltage can be generated. So it is used in say waste heat recovery, remote power generation. And finally, it is used in temperature control for precise temperature, and like it is used in say laser diode temperature stabilization, where it's maintaining a stable temperature for the laser diodes to ensure optimal performance, and it is used in crystal oscillator temperature control. Mm, so hope you understood the Peltier effect clearly. So let us take up some assessment questions. So in the Peltier effect, if the current is reversed, what happened to the heat at the junctions? So the options are: it is generated in the same way, it is absorbed instead of released, it is no longer affected, and it doubles in magnitude. Yes, the answer is it is absorbed instead of released. A thermoelectric cooler operates based on what principle? So we know that it operates based on Peltier effect. So the Peltier effect results in the transfer of heat between two junctions of dissimilar conductors when the reason is an electric current flows through the circuit. Thank you for watching this video.